In this example, we will be looking at how to apply the ideal gas law to solve ideal gas law problems. Now, a lot of the gas laws we learned so far apply very well to ideal gases, which basically we pretend that they have ideal properties and that their molecular sizes and intermolecular attractions don't affect their behavior. So in reality, that's not true, but for our sake, we will assume that. So, as a reminder, we'll first go through this question and we'll make a data list so that we can identify all the variables we know and what we don't know. So the question says the air in a person's lungs has 0.177 moles of gas particles at 310 Kelvin with a pressure of 101.3 kilopascals. What's the volume of air? So we're looking for the volume of the air in a person's lungs. So we know that N, or the moles, N still means moles. So 0.177 moles. We know that the temperature is 310 Kelvin. And we have to make sure we use units of Kelvin in the ideal gas law problems. We know that the pressure is 101.3 kilopascals, and we are looking for volume. And then R is the universal gas constant, which we know. And when we're using R, we just have to make sure that the units of R match up with the units of pressure, volume, and temperature that we are given. So our value of R, most commonly and in this example, is going to be 8.3145 liter kilopascal per Kelvin mole. Because then you'll see when we perform the calculation, the irrelevant units will cancel out. So we just have to make sure we're choosing the right universal gas constant based on the units that we have. So we know that the ideal gas law is PV equals nRT. This is a super classic law in chemistry, and if you go on to take chemistry in post-secondary, you will see this many more times. So we want to solve for volume. That's our unknown. So we need to make sure we isolate volume on one side of the equation. To achieve that, we can divide both sides by the pressure, because then it will cancel out on the left side of the equation. And then we know that volume is equal to moles times the universal gas constant times temperature divided by pressure. And then it's just a matter of subbing in all of our information. So N is 0.177 moles times 8.3145 liter kilopascals per Kelvin mole times 310 Kelvin, that's our temperature, divided by 101.3 kilopascals. And then just so that everyone can see why we're going to get final units of liters and why it's going to be a volume. So kilopascals, that cancels out. The Kelvin cancels out. The moles cancel out. And we're left with liters. So our final answer is going to be around 4.50 liters. Therefore, the volume of air in the person's lungs is 4.50 liters. So recapping that, we went through all the variables in the question. We extracted the relevant information and put it in a data list to figure out our given and our unknown. we set up our relevant equation performing algebra to isolate the variable that we wanted to solve for, subbed in all of our information down here, and then got a final answer.